much time. So if you see it like this, you know you're going to expand it by just taking it and moving it back out these many times. If you see it like this and they want you to change it to that, you're going to move it back as many times as it takes to get just one whole number there. You count how many times you move it, and that's the power of 10 that you're multiplying it by. They have some examples in here. Let's look on page 93. And it shows you first the powers of 10 to show you what they're talking about. The unit or 1 is just, the value of it is 1, and the power is 10 to no power. 10 to the 0 power is 1. You very rarely will have to deal with that. 10 is 10 to the first power. That means 10 written one time. 100 is 10 to the second power, which 10 written twice and multiplied by itself. 10 times 10 is 100. That's 10 to the second power, or 10 squared it's called. 1,000 is 10 to the third power. 10 times 10 times 10. 10 to the third power, or 10 cubed. You might hear it pronounced as well. Anything to the third power is cubed. The second power is squared. And then 10,000 is 10 to the fourth power. 10 times 10 times 10 times 10. And if you notice, you can tell the power by the number of zeros in the power of 10, as I talked about the other day as well. 1 0 in 10 is to the first power. 2 zeros in 100 to the second power. So it's easy to remember those. Okay? So, it's telling you how to change it to scientific notation and back. Look at the example on the bottom there. It says to write 7,300,000 in scientific notation. And you see they have taken the decimal point and moved it back so that only the 7 is in front. And they've moved it back 1, 2, 3, 4, 5, 6 times to get it there. That's why it's 7.3 times 10 to the 6. Okay? So let's look on page 94. And I want you to do number 1, 2, 3, and 4. Just do the first ones in each one.
Ones?
1, 2, 3, and 4, just the first ones. The ones in the first column. Okay, number 1 in scientific notation, 740 would be what? 7.4 times 10 to the second power. Everyone get that? And the 95 million would be
9.5 times 10 to the second power.
Everybody get that? 9.5 times 10 to the 7th. You have to move it back 7 times to get that decimal between the 9 and the 5. For number 3, how did you expand that? What is the whole number? For 2.74 times 10 to the 5th? 274,000. Everyone get that? And then 8.1 times 10 to the 4th? 81,000. Okay? Questions about that? So that's probably one of the easiest things you ever learn. But if you have that on a test and had never heard it before, you wouldn't begin to know how to solve those, and you think it's a lot harder than it is. It's not. Number 5, it says some experts believe that the population of the world in the year 2010 will be 7,240,000,000. Write the estimated population in scientific notation. What would that be?
Times 10 to the
7.24, you gotta use all the numbers that come before the 0, so 7.24 times 10 to the what?
9.
9, okay. Number 6, the temperature of the core of the sun is 27 million degrees Fahrenheit. Write this temperature using scientific notation. 7th power, right. 2.7 times 10 to the 7th. Then they want you to write the distance across the sun as a whole number. 8.65 times 10 to the 5th is what? What is that as a whole number? Ten to the 5th. 8.65 times 10 to the 5th. Anyone have that?
865,000.
865,000. You gotta move it over 5 times to the right. Move it 2 times, it'll get to the end of the 65. Then you gotta add 3 zeros to make it 5 times. So 865,000. And then the planet Pluto is 3,675,000,000 miles from the sun. Write this distance in scientific notation. You know it's gonna be 3.675, right? All you have to figure out times 10 to the what?
9.
To the 9, okay. Any questions? Blake, any questions about scientific notation?
No, I think I got it now.
Think you got it?
Yeah.
Practice it some more there. I left some problems there in 1 through 4. The second column and the third column, you can do those for some more practice. Again, it's just a matter of counting, making sure though that you have only one number to the left of the decimal. They give an example right there above exercise 12 that you may need to note that if you're doing it on a calculator, it's not gonna say times 10 to the, it'll just give you the 7.17, and that little 11 exponent there lets you know that it's times 10 to the 11, power, okay? I doubt that you'll be using a calculator to ever do that, but you just never know. So just so that you're not confused when you see it that way, it's just not, calculator display is just not big enough to put all that in there. So they will just let you know, they know that you realize it's 10 to the 11th power. Okay, so again, what I want you to just review, I want you to review all of the fractions. Make sure that anytime you have a fraction problem, you understand whether you're going to add, subtract, multiply, or divide, and then be able to do that. So that fraction review, and then the decimal review as well. On Tuesday, when we're back, we're going to start working with ratio and proportion, so then we can move into percent. A lot of folks have problems with that. Ratio and proportion is just a wonderful tool to use to solve problems. The gentleman that just came in here a little bit ago is our most recent class graduate, and he can tell you that a lot of those questions on that math test for GED, if he could set up a ratio and proportion, he could solve the problem using that. So that's a very good tool to be able to use, and we want to work on ratio and proportion.